Hello everyone, good morning. Why I'm saying good morning? Because I want you to get up early in the morning and then study. Survey says the person who studies early morning has more grasping than the late night. Anyways, today we are going to do chapter number 4, data handling part 2. So let's get started. In part 2, we will study few terms. First one is random experiment. What is random experiment? So any experiment which you do whose outcome cannot be predicted with certainty. Means suppose I took a coin, 1 rupee coin or any coin. When I toss this, I can get either head or tail. I don't know which one is going to come, correct? So in that case, this experiment is going to be known as random experiment. Same way, suppose you have a dice. Dice means जिससे हम लूडो खेलते हैं. So dice 1, 2, 3, 4, 5, 6. Any of the number can come, but which one will come, we don't know exactly. So there is no certainty. We can't say exactly pakka which number will come. So that is why we say it is a random experiment. Now, second term is outcomes. What are outcomes? So when I do an experiment means any activity which you are performing, who has some result. So outcome is nothing but the result of random experiment. So when I toss a coin, it is head or tail are the outcomes. When I roll a dice, so 1, 2, 3, 4, 5, 6, these are the outcomes, correct? Now, what are equally likely outcome? So equally likely outcome means when I do a random experiment, it has outcomes, but all the outcomes has equal chances to come. Like when I toss a coin, I can get either head or tail, and they have equal chances. If I toss coins 100 times, there are chances that most of the time, like approximately 50 and 50 times it will come, or maximum 48 and 52, or vice versa. So the chances are going to be equal. So these kind of outcomes, where a set of outcomes are event in which each outcomes has same probability of occurring, means same chances of occurring. What is exactly this probability? Let's see. So probability is nothing but the ratio of the number of favorable outcomes to the total number of outcomes. I'll tell you in a moment. Suppose I have rolled a dice whose outcome is this much. Now I want even number. So how many even numbers I have? 1, 2, and 3. 3 even numbers I have. So favorable means I think I want even number, right? So my favorable is 2, 4, and 6, which is total number 3. 1, 2, 3. And the total number of outcome is how many? Total are 6 outcome. So the probability is favorable, which is 3, and the total, which is 6. So probability is 1 by 2. The result says the probability is always from 0 to 1. See, 1 by 2 means 0.5. And yes, it is between 0 and 1. 0 probability is when the event is impossible. We will say it has 0 probability because it is impossible. For example, I'm rolling a dice and I'm saying I want 7 to come. But in dice, there is no 7. So it is impossible that 7 should come on the dice. So it is impossible and the probability is 0. 1 means certain, means the outcome is definitely that. Suppose I toss a coin and I said either head or tail is okay. So definitely in a coin, either head or tail will come. So in that case, it is pakka. So it means the probability is 1. Correct? Now, these are the only concept which we have before the exercise 4.2. Let's move to the exercise and do the first sum. So this is the first question. Sorry, it is not 5.3. It is 4.2. Because this is old book, so that is why it is like that. Correct? So it is 4.2. So first question says, list the outcomes you can see in these experiment. So spinning a wheel, in a wheel, I can see all these. So what is outcome? Outcome is A, B, C, and D. There is 2A, so I need not to write it. Only A, B, C, D are the outcome. And outcome are always written in a curly bracket, which is also known as braces or middle bracket. There are different names. So it's a curly bracket. We write outcome of an event in a bracket with separating them with commas. The second one is tossing two coins together. Okay. If I toss first coin, two coin I'm tossing, so I can get either head or tail, right? Now, as I'm tossing the two coins, first coin can have head and the second coin can also have head, right? If first coin has tail, the head, the second can have tail also. Same way, if the first coin, this is first coin and this is second, the number of combination I want to tell you. Suppose the first one is tail, second one can be head, or if first one is head, second can be tail. So number of combination is, just see the arrows here. It can be head, head, or it can be head, tail, or it can be tail, head, or it can be tail, tail. This is known as T diagram. Tree diagram. There is another method. What is that? Suppose the first coin can have head and tail. This is first coin. The second coin can also have head and tail, and see all the possible combination. And what is that? Suppose if I'm taking head, so this and this, that is HH, then this and this, which is head tail. Then second option, that is TH, and then this and this, that is TT. You'll get the same output as this. We also know that we need to put this into curly bracket and separate them with commas, which I already had done. So number of outcomes are 4. Clear? Let's move to the second question. Second question says, when a die is thrown, list the outcomes of an event of getting a prime number. So total number of outcome first. So total number of outcome, as it is a die, I'll get 1, 2, 3, 4, 5, and 6. Correct? Sorry. So first number says prime number. So first number is, prime number are what? Prime number are which get divided by 1 or number itself, right? So the first prime number is 2. 1 is not a prime number. Keep that in mind. The prime number, first prime number is 2. So 2, 3, and 5. They are the number which get divided by number itself or by 1. But 4 is not a prime because 4 is getting divided by 2 also. So the definition of prime number is that particular number get divided by itself or by 1. That's all. The second says not a prime number. So if you got the prime number, this is first ka A, and the B part is, so the B part is, it says not a prime. Not a prime means the one which is prime, remove that. So this is a prime, remove. This is a prime, remove. This is a prime, remove. Remaining is 1, 4, and 6. So they are not. The second part of it says, what it says, the first part, a number greater than 5. Greater than 5 means the one which is more than 5. So there is only one which is 6 is greater than 5, right? Sometimes even I don't know how to draw curly bracket. The B part, a number not greater than 5. So not greater than 5 means the number which is not more than 5. So I will say 1, 2, 3, 4, and even 5 is not greater than 5. It is equal to 5. So that is why I will include 5 also. Correct? Let's do the third question. Here is the third question. What it says? Find the probability of the pointer stopping on D in question 1A. Okay, so for that, I need to paste question 1. So this is my question 1. Okay, Control C, and I'll just paste over there to get the clarity. Okay, so again, as I said, this is question number, exercise number 4. What it says, find the probability of the pointer stopping on D. Okay, so I want this pointer to be stopped here. Okay, so what is probability? I'm solving the first part, A part. Probability is favorable outcome, favorable divided by total number of outcome, right? Okay. So favorable is only one, that is D. So it is 1. And total is how many? Total is actually 5. 1, 2, 3, 4, 5. So total number of outcome is 5. So the probability is 1 by 5. And check whether it is between 0 to 1. 0.2 is the answer. So yes, it is between 0 and 1. Second part says, B part, probability of getting an ace from a well-shuffled deck of 52 playing cards. So here you should know the playing cards and which all cards are there. So I'll just brief here. We have 4 kinds of card. One is this, and this is red color, known as heart, obviously. And one is this. It is also red color, and this is known as diamond. The next one is something like tree, like this, and it is known as spade. And the fourth one is like this. This is spade. And this is club, C-L-U-B. Okay, so these two are black color. It is kind of hard, but with this thing, stick, beetle leaf kind of thing. And this is like this tree kind of thing is known as club. And these two are red in color. So these are the 4 suits we have in playing cards. And each suits are in 13 number, means heart is 13, diamond is 13, all of them are 13. And that is why together they make 52 cards. Clear? Now, in one suit, means every suit, we have ace, then ACE, ace, then from number 2 to 10, which total is how many cards? 9. And this is ace is 1. And the remaining, I have jack, queen, and king. And they are 3 number. So total 13. These are known as, including ace, are known as number cards. And these are known as face card. Clear? So revision quick. Heart, diamond, club, and spade. We have 4 kind of suits. These 2 are red in color. These 2 are black in color. Each suits are 13 in number. So the first in every is ace. And I say the ace of heart, ace of diamond, ace of club, ace of spade, like that. And then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. These are like 9 cards. So total 10 number cards. And these 3, jack, queen, king, these are known as face cards. So total 13 cards in each suit. Now come to the question. So the B part says, probability of getting an ace from a well-shuffled deck of 52 playing cards. So ace, how many ace we have? 1 ace in each suit. So total I have 4 ace and number of card is 52. So cutting this will give you 4 ones are 4 ones are 4 threes are. So the probability is 1 by 13. Clear? You have to write the formula everywhere. The formula is probability is equals to favorable outcome divided by total number of outcome. This formula you have to mention everywhere. Okay. Now coming to the third part, the probability of getting a red apple. Okay. So here, can you see in the box? This is red apple, that is 1, 2, 3, and 4. I have total, if I need to calculate probability, this is favorable upon total outcome. F-A-V-O-U-R-A-L-E, favorable divided by total outcome. I'll just write the formula. So favorable, how many apple I have? 4. 4 red apple because I want red apple. So that is favorable. And total is how many? There are 7. So the probability is 4 by 7. This is the answer for third C. Clear? Okay, let's move to the fourth question. Here is the fourth one. What it says? It says number 1 to 10 are written on 10 separate slips. So I have 10 slips. 1 to 10 numbers are written, one number on each slips. Kept in a box and mixed well. Means they are trying to do random experiment. Means the probability, the chance of getting a number is equally likely. One slip is chosen from a box without looking into it. What is the probability of getting a number 6? So see, I have 10 number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Correct? So the total outcome is, how we denote? N is the number and S is the sample space. What is sample space? The group of total outcome is known as sample space. The group of total outcomes is known as sample space, S. So N is number. So total number is how many? 10. Correct? Getting a number 6. I have only 1 6. So the probability is favorable, that is only 6, which is 1 divided by 10. So the probability of getting 6 is 1 by 10. See the second one. Getting a number less than 6. Less than 6 means 6 is not included. Less than that. So I have 1, 2, 3, 4, 5. So 5 numbers are less than 6 and total is 10. So 5 ones are 5 twos are. So the probability is 1 by 2. Getting a number less than 6 is 1 by 2. Coming to the third part. What it says? Getting a number greater than 6. In greater than 6, again 6 is not included. So how many? 1, 2, 3, 4. So 4 number are there which are greater than 6 and the total is 10. So just do the cutting. So the probability is 2 by 5. Fourth, getting a 1-digit number. 1 digit means, suppose if I say 5, it is 1 digit. When I say 26, it is 2 digits. So 1-digit numbers are how many? Up to here means 9 number. So the probability, the favorable, the things I want is 9 divided by 10. So the probability is 9 by 10. Let's see the next question. Fifth, which is last one. No, there is one more, sorry. So let's see the fifth one. If you have a spinning wheel with 3 green sectors, 1 blue sector, 1 red sector. Okay, so I need to make a spinning wheel. Total is how many? 3, 1, 1. Matlab 3 plus 3 green sectors, 1 blue sectors and 1 red sector. Total I have 5. Okay. So 1, 2, 3, 4, 5. So I'll write green, green, green. I'll write blue. I will write red. Correct? So if you have a spinning wheel with 3 greens, 1 blue and 1 red sector, what is the probability of getting a green sector? So probability is what? Probability is equals to favorable outcome divided by total number of outcome. So favorable number of outcome is, I want what? Green color. So 1, 2, 3. I have 3. And the total outcome is 1, 2, 3, 4, 5. I have 5. So the probability is 3 by 5. Second part says, what is the probability of getting a non-blue sector? Non-blue sector means I don't want blue. So I'll just write P for probability and for what? Non-blue sector. This is the method to write. Probability, P stand for probability, non-blue sector. So again, favorable upon total. What is favorable? I don't want blue. Non-blue means I don't want blue. So I have 4. Correct? Non-blue or red is also non-blue. Green is also non-blue. So 4. And upon 5. So non-blue, probability of getting a non-blue sector is 4 by 5. Correct? Let's move to the next, which is the last. Find the probability of event given in question 2. Okay, so that is why I pasted here question 2. Probability of getting the event. Okay, so I have thrown a dice. So outcome is 1, 2, 3, 4, 5, and 6. Now it says prime number. So first A, right? It says prime number. So what is prime number? 2, 3, and 5. So what is the probability? The total number of outcome is 6 and the favorable is 3. So the probability of prime number is what? 3 divided by total, which is 1 by 2. Correct? Let's see the B part. It says not a prime number. Not a prime numbers means 1, 4, and 6. So probability of not prime is what? Favorable is 3 and total 6, again 1 by 2. Notice one thing here. When I find the probability of something and not the same thing, means probability of prime and probability of not prime is always 1. Suppose I find the probability of getting head and the probability of not getting head, the sum of these two will always be 1. So this is the formula. Probability of something and probability of not something is always 1. Clear? Okay. Let's move to the second part. So I'll write the same pattern, Roman number A. A number greater than 5. So number greater than 5 is how many? Only 6. That is 1. And the total number of this is 6. Here total outcome is 6. So the probability is 1 by 6. The second part, a number not greater than 5. Not greater than 5 means the one which is less than 5. So that is 5 numbers including 5, because 5 is also not greater than 5. So it is 5 by 6. So see, the probability of getting greater than 5 and not greater than 5, add these two, it has to come 1. So 1 by 6, 5 by 6, which is 6 by 6, and yes, it is 1. So this rule is valid. Correct? So this was about the 4th complete chapter. After this, we will start chapter number 5. I'm going in sequence so that it will be easy to cover up the things. Okay? Chalo. Bye-bye. Take care and happy studying.